Hi everyone, Jason from Makera here with another project tutorial video. And in this one, we're looking at how to use Makera CAM to design and manufacture a custom bottle opener machined with the Carvera Desktop CNC. We'll specifically be looking at how Makera CAM can import 3D models to be prepared for machining, as well as how the Carvera can machine a range of materials from wood to metal. But we'll also look at how you can customize this project to fit your own style and needs. So let's dive in. You can download the example models used in this tutorial from the knowledge sharing page on our wiki site, as well as the completed Makera CAM files that we'll be creating throughout this tutorial. All right, so after downloading the files that you need from our wiki site, you can, of course, launch Makera CAM and create a new 3-axis project starting for the handle part of this design. And whenever you make a new project, the first thing you want to do is adjust your stock. So I'm going to be working with a piece of hardwood, some walnut, that is about 80 millimeters in length and 130 millimeters in width and about 20 millimeters in height. But you can, of course, adjust this to match whatever size stock it is that you'll be working with. So I'm going to press OK to confirm those settings there, right? And then I'm going to import the handle STP file that I downloaded from the wiki site. And there we go. So you can see we have our STP file, which fits this stock really well, but you can, of course, modify the file size a little bit if needed, or design your own custom handle, which we'll get more into later in this tutorial. But now with this 3D file imported, we can go ahead and create our toolpaths. And we're going to need several toolpaths, but we're going to use the same tool for all of them to keep things nice and simple, though that doesn't have to be the case. And I'll talk through a couple options as we go here. So the first thing we'll start is machining out this cap opening here. And we'll start by machining this larger circle at the top, and that'll be done through a 3D pocket toolpath. So whenever you do a 3D toolpath, we can actually select the face, and that will automatically choose our end depth. So we're starting from the top of our stock, and the end depth will machine to whatever the selected face is that I have here. So that would be this circle part here. Now, as far as tools go, as mentioned, we're going to do this all using a single tool. So I'm going to select my 25 millimeter end mill for hardwood, which will be chosen automatically based on my stock. This is quite a bit longer than what we need. So you could do this with a shorter bit, say, for example, a 12 millimeter single flute end mill instead. But you will need the longer one later on. So if you do want to do this without any tool changes, if you're doing this with, say, the Carvera Air, for example, this bit will work just fine for everything we have to do. So with that bit chosen, I'm not going to adjust any feeds or speeds. I will keep step downs enabled, so that way it just gradually works through this pocket here as we go. In terms of path strategy, we can do offset, which usually works really nicely for clearing out circular and smaller pockets like this. And we're going to keep outside boundary enabled for tool containment, which will allow it to machine the entirety of this pocket. You don't need ramping if you're making this with a softer material like wood, but if you were making this handle out of, say, brass or aluminum, you'd want to enable ramping, as it will gradually enter the stock with your bit. So I can calculate that, and you can see that we have this first pocket machined here, right? So that looks perfect as we machine through our part. Let me close this down. And if you want, you can hide your toolpaths to make seeing your part a little bit easier as we prepare our next toolpath. So let's create another 3D pocket. And what Makera CAM does is it keeps whatever the previous settings were if you make the same type of toolpath again. So for example, you'll notice that I have the same tool, the same feeds and speeds, the same strategy and all that stuff that I just set previously, which is really nice. So the only thing I have to do for this new toolpath is select my new face I want to machine to, which would be this inner face. So I'm going to click on that face and then calculate. And now we're clearing out that area with our second toolpath, which is really nice. Now what we're going to do is we're going to machine these holes. Right, so we're going to create these holes here, and we can do that through a drilling operation. So let's create a 3D drilling toolpath. I'm going to select the bottom faces of my holes here, although I want to point out that if there were no bottom faces, let's say you're drilling all the way through, you can also select, let's say, the side of a hole instead. So whatever geometry works best for your design. So I'll select the bottom faces and we'll drill up to that. And if you want, you can do a drill tip offset. So for example, if you want your drill tip to plunge, let's say, 0.2 millimeters past the bottom to make sure that the entirety of the hole is drilled, you can do that. These are just going to be some pilot holes for some screws that we're going to use. So that's not crucial for this project, but something to keep in mind for other projects. And then you need to select your tool. So you can do this using a 3.175 millimeter drill bit, like I have selected by default. But I mentioned earlier that you could do this whole project with a single tool. So if I go back and choose my 25 millimeter end mill that I chose earlier, I can actually do a drilling operation with this single flute bit. So that's perfectly fine. So you could use a drill bit if you had one and you want to do a tool change, or again, you can keep using this same 25 millimeter end mill. Now we do want to enable a retract, even though this is such a shallow hole, right? That will just stop it from plunging all the way down. So this will do a gradual step down through like a peck drilling operation. So it will gradually peck and create this drilling operation with our end mill. So with all that selected, we can click calculate. And I'll just show all of my paths here, and you can see that we've successfully cleared out now this cavity for the cap. So all that's left is to cut our part. So cut our part out of the stock. And that's going to be done through a 3D contour toolpath. So I'm going to select my 3D contour toolpath, and what we have to do is we have to generate contours. And you can do this either based on an object or a face. In this case scenario, object would work fine because I want to actually create the contour around this outer object. So I'll select my object and I'll click Generate Contour, and you'll see that a couple different lines will be created automatically. This outline is, of course, the one that we actually want to machine. So the end depth is going to be calculated automatically. So it's going to find the height of my part and set that. And because this is a 20 millimeter high or thick part, it automatically set my end depth to be 20 mil. But let's say I want to machine a little bit past, like for example, 0.2 millimeters, just to make sure I cut all the way through my stock. You can add an offset on just like this. For our tool, we want to select the same 25 millimeter end mill that we've done previously. I won't change any of the feeds and speeds. This is all fine. For the strategy, we want to run along the outside, so that way the tool will run around the outside of this handle design, like so. And we want to enable tabs, right? So that way what tabs will do is they will hold on to this part during the machining process to make sure it doesn't eject out of the stock. So that's a really important thing. And you can cut them off with a handsaw in post-production. So you can create triangular or rectangular tabs. For wood, I typically prefer rectangular tabs, but because this is a curved surface, I don't really have a straight edge. Sometimes triangular tabs cut off a little bit easier. So you can adjust the size. I'm going to make these about 15 mil wide and let's say 3 millimeter thick. And I'm going to add 2 tabs on either side of my handle part, like so. And then I can click calculate to calculate this toolpath. And you can see there are our little triangular tabs that again can be cut off later. So I'm going to close this out. That concludes the toolpath generation for the handle part of this design. So all that's left now is to right-click your paths, save them, and if you wanted to reassign your tool numbers or double-check your tool list, you could do that really conveniently here. But as you can see, we're using tool 1, the 25 millimeter end mill, for each of these toolpaths. So I can just save this as a G-code file and get ready for the next step. Now, before we look at preparing the cap file for this project, let's manufacture the handle with our desktop CNC. The first step is to secure your stock to the bed of your CNC using a combination of clamps and screws, ensuring that each side of your stock is secure. You also want to ensure that there's a piece of wasteboard on the bed of your CNC, as we'll be machining all the way through our part. We can also load the tools in the Carvera's automatic tool changer or prepare the tools that we'll be needing if you're using the Carvera Air. For the handle part, based on how we prepared it in this tutorial, we will only be needing the 25 millimeter end mill loaded into tool slot 1. Next, we can launch the Makera controller app and upload our G-code files created in Makera CAM to our CNC. With the handle files uploaded, you can preview it in the controller before opening the config and run window. Here, we can adjust the position of this part on the bed of our CNC as needed to ensure it's placed on our stock and away from any clamps. Enabling scan margin will trace the perimeter of your design before machining so you can check this position as well. Auto Z probe should be enabled, which will use the Carvera's wireless probe to automatically measure the height of our stock before machining. And auto leveling can be used if your stock isn't flat or if it's rough cut or warped, as the Carvera will measure the height in several points and compensate for any deviations automatically. Once your parameters are set, press Run to start machining this part. After completing the scan margin and probing sequence, the Carvera will automatically select our tool 1, the 25mm end mill, and begin to machine our part. This will start by machining the different pockets where the cap will be placed, as well as in the drilling operation that we've selected too. Lastly, the outer perimeter will be machined through the contour toolpath while keeping our part secure using tabs. After machining finishes, use a vacuum to clear any dust and then remove your part from the machine. We'll get into assembly later on, but let's now prepare the cap part for this project using Makera CAM. Alright, so now for the cap part, back in Makera CAM, we can create a new 3-axis project, and we can adjust our stock as the first thing, just like we did before. So this part's going to be made out of aluminum, though you could choose a different metal if you'd like, and I'll show that later on. So I'm working with a piece of aluminum that's 200 in length, 100 in width, and 3 millimeters in height. And the length and width is less important. It obviously needs to be big enough for the part. I just happen to have a larger piece of aluminum laying around for this project that I'm going to use. The height is the important part based on the design that we're going to import. So you want to make sure that you're working with a piece of metal that is 3 millimeters in thickness. With our stock set, let's go ahead and import the 3D model for the cap, right? So here's our cap part. And I'm just going to reposition this using the transform tools to just move it a little bit closer to my origin position here, like so, just to save some material when I actually go and machine this part. So there are a number of features that we need to machine through a couple different tool paths and a couple different tools as well as we work to create this part. So the first thing we're going to do is we're going to create a pocket operation to clear out this cutting part of the tool here. So let's create a 3D pocket toolpath. All right. I'm going to select the face that I want to machine, which will be just this smaller face here, as you can see. The end depth will be set automatically, as we talked about earlier, but I do want to use a different tool for this. In general, you want to use the shortest tool possible when working with metals to make sure there's not too much overall load on the length of your tool here. So I'm going to select my 3.175 by 12 millimeter end mill with the default feeds and speeds set for aluminum. Now, for the path strategy, we could use offset or parallel to clear out something like this. In general, offset typically works better for a smaller pocket area like this, so I'll choose offset. And again, we're going to keep outside boundary just to make sure that we machine the entirety of this. One thing that we didn't do for the handle was ramping, and as this is a much harder piece of material, I'm going to enable ramping with just a distance of 10 millimeters and an angle of about 3 and a Z height of 1, which usually works well as a good default starting parameter for ramping. So with that set, I'm going to click Calculate and calculate this pocket here. Excellent. So the next thing we have to do is we have to machine this opening that we have here for the rest of the bottle opener cap part here, as well as we have the 2 screw holes too, which we can machine as well. So for that, I could do a pocket, but that'll take quite a bit of time to kind of clear and machine all this area. Instead, I'm going to do a contour toolpath, which will just follow around the perimeters of the design. So let's create a 3D contour. And we're going to generate the contours. What I'm going to do a little bit differently though, is instead of generating the contours based on the object, I'm going to generate the contours based on the face. And specifically, I'm going to generate the contours based on the bottom face. So that way I actually grab just this opener contour, not necessarily the pocket part that we've already machined, because I don't want to actually cut off that pocket part. I want to keep that machined pocket part in my design. So I'm going to click on the bottom face and then click Generate Contours. I'm then going to hold Shift and select the contours for my 2 holes and the openings, as all of these contours are going to be machined to the same depth with the same feeds and speeds. I am going to offset the end depth just a little bit, so I'm going to machine, let's say, 0.2 millimeters past my stock, just to make sure I machine all the way through. And I'm going to use the same tool and the same feeds and speeds that I did earlier. So I'm going to select my single flute 12 millimeter end mill set to aluminum for my feeds and speeds. Now for this contour path, we're running along the inside of our selected path. So we machine along the inside of our design, like so. We do want to enable ramping. I'll keep the same settings that I had earlier. And I also want to enable a tab just for this larger piece of material here. These smaller holes are going to be almost no material at all after machining out with our bit, so just small shavings. But this larger piece is going to be quite large, and I don't want it to fly out, eject, or potentially get stuck or break my tool. So I'm going to enable one tab. I'll use triangle, and I'm going to set this to be a tab thickness of 1 millimeter. I'm going to add just one tab right here on this flat spot in my design that I'll be able to cut away. So that should keep this centerpiece in place during the machining process. So I can calculate those contour paths. And you can see, if I rotate a little bit, you can see our triangular shaped tab there. Now to cut out this actual part. So we're going to need another 3D contour, but with slightly different settings. So first off, we can generate a contour around the object now, and we're going to machine this outer contour like so. I'm going to keep the same end depth offset as 0.2 millimeters to make sure I machine all the way through. I'm going to keep the same tool and feeds and speeds, but this time around we're going to run along the outside of the path, not on the inside. We want to enable ramping just like we did before, and again we want to create tabs. So I'm going to add 2 tabs on the outer perimeter of my part just to hold it in place during the machining process, and I can click calculate, like so. So now what we've done is we've successfully machined this part as you see it here, but we can add a couple more toolpaths just to make it a little bit more aesthetically pleasing and also perform a little bit better too. And those toolpaths would be chamfering toolpaths, which will add a chamfered edge on certain features of your design. The first chamfering toolpath we'll create, if we make a 3D chamfering toolpath, will be for this outer edge. So I'm going to click on the face of my design, the top face specifically, and generate a contour along the top of the face here. If I just rotate around, you'll see that I have this contour selected. For my chamfering depth, for the size chamfering bit I'm going to use, a chamfering depth of 0.5 millimeters works pretty well, and a tip offset of 0.2 millimeters also works pretty well. You're going to want to use the chamfering bit that we have in our example pack, that we have our 0.1 millimeter by 90 degree chamfering bit with the feeds and speeds set to be for metal. And as we're machining along the outside edge, we want to make sure that our strategy has an outside profile. So I'm going to calculate that chamfering path. You can see here that we have a very small chamfering path created along the outer edge. Now, if you want, you can also create a chamfering path along the inner edge. This has to be a different tool path as we're using a different machining strategy. So I'm going to create one more tool path, a 3D chamfering one. I'm going to select the face of my part and generate the contours. And this time I'm going to select my 2 holes and this bottle opener profile here. I'll keep the same tool, feeds, and speeds that I did for my last chamfering path, but for this one, we're going to be running along the inside of the profile, not on the outside. So we can calculate that, and we can see that we have another nice little chamfering path here for these parts. So with that done, we've prepared the CAM aspect of this second part of our design. So again, all we have to do now is save these paths as G-code files. If you want to make any adjustments to your tool numbers, you can do that here before moving on to the next stage for manufacture. With the cap part prepared, let's get our CNC machine ready to manufacture the second part of this project. Again, we can secure our stock to the bed of our CNC using a piece of wasteboard and clamps as we did before. We can also prepare and load the tools that we'll be needing for the cap part, which includes the 12mm end mill in slot 4 and the chamfering bit in slot 6. And whenever we machine metal, we typically remove the dust boot, and instead of using the internal vacuum of the Carvera, we use the Air Assist system for chip evacuation and cooling instead. Back in the Makera controller app, upload your cap G-code and head back to the config and run window. We can again adjust our offsets, enable scan margin and auto Z probe and auto leveling as we did earlier. Once your parameters are set, press run to start machining this part. After completing the scan margin and probing sequence, the Carvera will automatically select the 12mm end mill to begin machining this part, starting with the small pocket before machining the inner contours to create the opening and screw holes. The outer perimeter will be machined through the contour toolpath while keeping the part secure using the tabs that we created. Lastly, the chamfering bit will be selected and used to create a chamfered edge using the 2 toolpaths we created earlier for both outside and inside chamfering operations. After machining finishes, use a vacuum to clear any shavings and then remove your part from the machine. For assembly, we can carefully cut and sand away the tabs holding our parts before assembling them using small machine screws in the pilot holes our machine created. But that's not all there is to it. With a project like this, there are limitless possibilities as you design and create your own custom bottle opener through this project. For example, you could use Makera CAM to import an image and prepare it for a laser engraving to create an engraved custom logo on the back of your opener using the Carvera's built-in laser module or the optional laser module on the Air. You could also create this handle out of a range of materials and shapes to customize the design and function too. To make this easier, we also shared a 2D profile for the handle design on our wiki site that will allow for you to easily customize the handle shape while keeping your design compatible with the cap part that we prepared earlier. For example, you can use Makera CAM to import another vector file or even just an image like this one and trace it to scale it and create a truly unique project. After that, all that will be left is to manufacture your designs and enjoy. Check out our YouTube channel and wiki site for more tutorials and features that we demonstrated for Makera CAM and the Carvera and Carvera Air Desktop CNC. And of course, please don't forget to subscribe, and thank you for watching.